Hi guys, it's Inventor Andy, and today we're going to be looking at I2C communication. To do this, we're going to be using the TE Connectivity TSYS01 Extension Board, which can be found on DigiKey. It's a digital temperature sensor that uses I2C or SPI for communication. To save a bit of time, I've already pre-created the project in Atmel Start, so I'll just quickly run through the settings with you guys and explain what we've got. As you can see, we've got Thesis, which is using the I2C master sync driver, and we've got that on PA09 and PA08, which is the Extension 1 header on the Xplained Pro board. We've also got our UART debug, so we're going to use USART sync for this, and we're using PA23 and PA22 for our UART lines, which is what's used for the virtual COM port. Don't have to change any of the other settings. We've got 9600 baud rate, and finally we've got our timer driver, which we'll keep with the default settings. We're just going to use this to take a reading every second on the I2C line to get a sensor reading. Okay, so I'm going to go ahead and export this project. Go ahead and save that. Okay, so let's go ahead and open this project in Atmel Studio and we'll get started. Okay, so the first thing we're going to do is we're going to create a library for the TSYS sensor. So if we go and click add, we're going to click new item, and we're going to add an include file, a header file, and we're going to call this ext TSYS01. Now, the reason we're creating a library for this is if we use it in any other projects, we can just pull these files in, and it makes everything a lot easier and saves you a lot of work down the line. So first off, let's include our driver initialization. And next we're going to create a struct for our I2C IO. And then we're going to define some commands. Now these commands are in the data sheet for TSYS01. So if I just move this to one side. Let's find our commands. Okay, so these are our commands. Zoom that in a little bit. So our first one is 0x1e, which is our reset command. Our next one is to start the ADC temperature conversion, which is 0x48. And the next one is to read our ADC conversion, which is 0x00. So the way this digital temperature sensor works is we start an ADC conversion, an analog to digital conversion on the sensor, and then when that's complete we read the value back, and then we apply a calculation to it to convert that into a temperature in degrees C. So the calculation is based on some values that are stored on the chip in PROM. And these are at 0xA0, 0xA2, 0xA4, 0xA6, 0xA8, 0xAA, 0xAC, 0xAE. So these addresses, we've basically got 2 bytes between each one. Okay, next up we need to define some coefficients which we use for the calculation. So what we're going to use is these coefficient multipliers here. So the first one is minus 1.5. Now we need to make sure we define this as a float. The next one is 1. And then minus 2. Four. And then minus 2 again. Now let's define our number of EEPROM elements, which we've defined the addresses of here, and there's 8 of those. Okay, so that's all of the definitions we need. Next up, we're going to create our methods. So, we can have an init TSYS method, which will initialize the sensor. A read coefficients method, so we can read the coefficients from the EEPROM. Function to read the EEPROM, and finally a function to read the temperature. Okay, so that's our header file for the TSYS extension library. Now we're going to go ahead and we're going to create create the library itself. So let's add a new file. And this is going to be a C file, and we're going to call it ext TSYS01. First off, let's include our header file. Now we're going to create a flag for whether we've read the coefficients. And we'll set that to false initially. Now let's define our coefficient multipliers. Let's create an array for our prom elements. And finally, let's create a value for our ADC reading. And we'll set that to 0 initially. Okay, let's create our initialization function. So this is where we initialize I2C on the board, and we set the slave address. So the way I2C works is that you can daisy chain multiple elements onto a single I2C line, and what you do is you send an address to all of the devices, and the device that responds to that address is the one that will send the response back. Sometimes these are predefined addresses on the component. Sometimes you can define them yourself. So let's initialize the I2C communications. So let's get the I/O descriptor. Save it to the one that we created. Now let's enable I2C, and then we're going to set our slave address. So I2C set slave address. So we've got two slave addresses here, and the one we're going to be using is 0x77. Next up, we're going to reset the device. Send a 1-byte command with TSYS-cmd reset. And we use the I/O write function to send the command. And then we're going to delay. that device time to reset. So our next function is going to be to read a single coefficient from the device. And then we save that in our coefficient array. Create a read buffer. That's where we're going to read the results. And we'll zero that out to start off with. Now let's create a write command. That's going to be our command that we specify in the function parameter. And then we're going to write that command. So give that a short delay to allow it time to respond. And then we're going to read 2 bytes back. So I2C is synchronous. You send data and then you receive data on the same line. You can't have data being sent and received at the same time. The disadvantage of that is obviously that you can't exchange data like on SPI, but the advantage is that you only need one I/O line for the data and one line for the clock. So let's do I/O read. We're going to convert this to a 16-bit unsigned, so we've got 2 8-bit unsigned there. And we do that with a bit of bit shifting. So okay, next up we're going to create our function for reading all of the EEPROM. So let's create a counter for the loop. And then we're going to loop through our EEPROM elements. So we'll read the coefficient from EEPROM. And we're saving that in the EEPROM coefficient array that we created up here. And then finally we're going to set the flag. And this means that we know that we've read the coefficients from the EEPROM. So our final function is to read the temperature. Okay, so let's create a temporary float for our temperature. Now let's create our command array. And we'll set that to be one value, and we'll zero it to start off with. Okay, so next we're going to check if we've read the coefficients, and if not, we're going to read them. Next up, we're going to tell the temperature sensor to start the ADC conversion. Then we're going to give it a delay to complete that conversion. Then we're going to send the command to read the ADC. Give that a short delay so that we can get a response. And we're going to create a buffer for our results. Let's scroll up here so you can see it. Now the ADC is a 12-bit value. So we'll create 3 empty bytes. And then we're going to read the result. So IO read TSYS IO. We'll still like to buffer at position 0. And we're going to read 3 bytes. Now we're going to convert this to a 32-bit unsigned. So ADC equals buffer 0 left shift 16 or buffer 1 left shift 8 or buffer 2. Okay, so we've got the conversion calculation already mapped out here, so we just need to convert this to code. So first off, we're going to divide by 256. So ADC divided by equals 256. Create a counter for our for loop. And then we're going to loop through and multiply by each coefficient. So we're going to go through these. So And we actually start with the last one first. So I equals 4. I is greater than 0. I minus minus. So we're actually looping backwards here. So temperature plus equals the current multiple that we're on, multiplied by our EEPROM coefficient, our position 1 plus 4 minus I. And then we're going to multiply that by our ADC of 100,000. Next up, we multiply our value by 10. Add the final coefficient. Divide by 100. And that should give you our temperature. So that's our library created. Our next step is to go to our main file and do a quick demonstration of this. So, I'm going to include a few extra files here. We'll include the stdio library. And then we're going to include our TSYS library that we just created. So let's create an IO descriptor for our virtual COM port. So create a timer task for reading the temperature at a set interval. Create a float for our temperature. Set that to 0. And then let's create our strings for printing the temperature. Okay. Now we're going to initialize our UART. Next up, we're going to create our timer callback function. this is the function that's going to get called by the timer to read the temperature. And we're going to save the value into our temperature float that we just created. And we're going to convert that float value into a string. So GCVT, which is an stdio function for converting floats to strings. So we'll convert temperature with 5 digits, and we're going to save that to our buffer object. Next up, we're going to create the reading string. Printf, so temp output starting at 0. Alright, temperature is %s, which is our string placeholder C, because we're reading in degrees C, and then we'll create a new line. And then that's use our buff object to insert into that string placeholder. Finally, let's write that value to console. Okay, our next function is to initialize the timer. Let's set up our timer. So we're going to set that to a 1 second interval. We're going to call the read temperature callback function, and we're going to repeat this. Now let's add it to the queue. Start our timer. Okay. Now, finally, we can get to our main function and get everything running. So, first off, we're going to initialize the Thesis temperature sensor. So, init Thesis. And then we're going to read our EEPROM. Next up, we're going to allocate some memory for our temperature string. Let's give that 30 bytes. Now let's initialize the UART and the timers. Okay, now because we're using a timer function which causes an interrupt, we don't have to do anything in our while loop. Everything's already been set up and it will do it on its own. Okay, so if we go ahead and build this, make sure we've got no problems. And it looks like everything built okay there. Okay, so if we go ahead and run our project, and then go to our data visualizer, you can see the temperature is being output there. So as a quick test, I'm going to put my thumb on the sensor to heat it up, and we should start to see the temperature rise. You can see we're jumping up to 29 degrees, up to 30, and now I'm going to take my thumb off the sensor, and you'll see it start to drop down again. that's a demonstration of I2C and reading from a digital temperature sensor. Thanks for watching, guys. I'll speak to you soon. Hi guys, it's Inventor Andy here. Thank you for watching my video. If you like the video, please click like, please subscribe to my channel, and please feel free to add any comments if you've got any suggestions for tutorials or videos that I can do. Thanks very much, guys.